Hello, welcome to the course Classical Orbital Elements, Kepler's Equation and Baker's Equation by Dr. Anshola Ogundele. In this presentation, I'll be going over the modules of the course, and we are starting with Module 0 course preview. In this preview, explanation on what the course entails is contained. Module 1 is about radar stations and classical orbital elements, and is divided as follows. Module 1 Section 1, radar stations. Module 1 Section 2, classical orbital elements. Module 1 Section 3, determination of orbital elements from position and velocity vectors, and vice versa. And Module 1 Section 4, determination of position and velocity elements from orbital elements. In Module 1, a quiz is given in order to enable students to be able to recap what was learned in the module. Module 2 is about time-since periapsis and special case of circular orbit. This module is divided into sections as follows. Module 2 Section 1, time-since periapsis and its applications. Module 2 Section 2, development of time-since periapsis equation. Module 2 Section 3, special case of circular orbit is described, and Module 2 quiz is given for students to be able to recap what was learned in the module. Module 3 is about Kepler's equation for elliptical motion, and is divided as follows. Module 3 Section 1, elliptical orbit Kepler's equation. Module 3 Section 2, Newton-Raphson Kepler's equation root finding method. Module 3 Section 3, practical implication of the elliptical Kepler's equation. And Module 3 quiz is given for the student to be able to recap and recollect what was learned over the course of the Module 3. Module 4 is about Baker's equation for parabolic motion. It is divided as follows. Module 4 Section 1, the Baker's equation. Module 4 Section 2, practical implication of the Baker's equation. And the Module 4 quiz is given for the students to be able to recap what was learned in the module. Module 5, Kepler's equation for hyperbolic motion, is divided into sections as follows. Module 5 Section 1, Kepler's equation for the case of a hyperbolic trajectory. Module 5 Section 2, Newton's method for solving hyperbolic Kepler equation. And Module 5 Section 3, application of hyperbolic Kepler's equation, is described in this module. Module 5 quiz contains the quiz for the module, and also to enable students to recap what was learned. In Module 6, example questions are given and answers are provided, and the module is divided as follows. Module 6 Section 1, example question 1. Module 6 Section 2, example question 2. Module 6 Section 3, example question 3. And Module 6 Section 4, example question 4. The last module, Module 7, is about exercises, which are given for students to be able to know how to apply the equations derived in the course. It is divided as follows. Module 7 Section 1, Exercise 1. Module 7 Section 2, Exercise 2. Module 7 Section 3, Exercise 3. And Module 7 Section 4, Exercise 4. Thank you for your attention.